For the second video dealing with cofunctions, we are going to interweave two topics that you've already talked about. One of them is the special right triangles, and then one is the cofunctions. So if we take a look at the two triangles that we see here, we can see that in our first triangle, it's a 30, 60, 90. And in this 30, 60, 90, I am told that the side across from the 30 is 1. Now, we've talked about this already, so we know that that means that our A value is equal to 1, which means that our side across from the 90, which is our 2A side, has to equal 2 times 1, which is 2. And then across from our angle of 60 degrees, we have our A radical 3 side, which means that this side is 1 radical 3, which we know is just radical 3. In the second triangle that you see here, it's a 45, 45, 90 triangle, and instead of having a 1 here across from the 90, I'm going to have this be a side of radical 2. We know that this is our A radical 2 side, which means then that our A value for both of the two legs of this right triangle has to be 1. So not only is this a right triangle, but it's also isosceles. So in this, we are going to focus on the sine of the angles. So we're looking at sine, and sine of 30 degrees, so we go to our 30-degree angle in our triangle. We have opposite of 1 over hypotenuse of 2, so sine of 30 is 1/2. If you type that into your calculator, that's exactly what you'll get. We then have to move on to the sine of 45. So when I do the sine of 45, I'm going to do 1 over radical 2. Now, if I have 1 over radical 2, we've spent enough time talking about radicals now that you know it's illegal to leave them that way. So I need to rationalize the denominator and end up with this as my answer. So it's radical 2 over 2 for the sine of 45 degrees. And then I move on to my 60-degree angle. And with my 60-degree angle for the sine, it's opposite over hypotenuse. So radical 3 over 2. And if you use your calculator for the sine of 90, you will get 1. And the sine of 0, you will get 0. They're asking us, now that we have those values of 0 for the sine of 0, 1/2 for the sine of 30, radical 2 over 2 for the sine of 45, radical 3 over 2 for the sine of 60, and 1 for the sine of 90. They're asking us to use our rule for cofunctions to fill in the cosine of all of these angles, which means that I'm going to make a little equation here, which means that if I know the sine of 0 has to equal the cosine of the complementary angle, which in this case is 90, whatever I get for sine of 0 has to be the same thing that I get for cosine of 90. So this 0 that's here also has to end up over here. So in other words, this one has to match this one. Using that same premise then, that means that the sine of 90 has to equal the cosine of 0. So those two have to match as well. I'm using the cofunctions and the complementary angles here. If I move on and I talk here about the sine of 30, I know it has to equal the cosine of, in this case, 60. These are cofunctions. They'll be equal if the angles are complementary. So that means that whatever I got for the sine of 30 has to be the same answer as the cosine of 60. And vice versa. So the sine of 60, what I got right here, has to be the same thing that I'm going to get over here, radical 3 over 2. And then this radical 2 for sine of 45 has to equal the cosine of 45. So although these two kind of change, they're also the same exact thing, so there's not much we need to do with them. Now, you could go through, if you wanted to, and go back to the 60-degree angle and do the cosine adjacent over hypotenuse, and you will find out that the cosine of a 60-degree angle is a half. However, if you can figure out the sine table, which you have right here, we know the cosine one is exactly that one, but in reverse when we go through and do that. So that kind of makes it easy for you to go through and remember that. If you remind me in class, I will give you a real quick shortcut on how to go through and fill in this table so you don't have to memorize and you don't have to draw those triangles every single time you go through to do this.